Hi, this is Mr. Cappert. This is Statics Part 2. Make sure that you have done Statics Part 1 before watching this video. This video will not make as much sense due to I went through what statics was, how to draw free body diagrams, that kind of thing before this. So make sure you watch that first. So now we're going to apply the statics to a truss bridge like we are making. Now on a truss bridge, you're always going to have one side that is pinned, one side that has a roller. This is to allow for thermal expansion. So when it gets warm out, this steel is actually going to expand. It can be as much as a couple feet. When it gets cold, it contracts by possibly a couple feet. If you didn't have a roller on this end and it was fixed, this would buckle. It would bow like this. Same thing if you have a car going over it, that's going to cause this to kind of bow downwards and kind of lengthen. And if it didn't have a roller, there'd be a lot more stress on it and potentially crack the concrete decking. And I'll show you a picture of that actually. You may or may not have noticed this before, but anytime you see a truss bridge, you have rollers on one end, such as this one or that one. Now, you need to draw a free body diagram of this. In order to do that, a pin always has two forces. It's replaced by two forces. It's holding the bridge up from falling down into this river, and it's also holding it from going left to right. Now, it's arbitrary which direction you choose. We don't know in this case if it is holding the bridge to the left or it is holding it from going to the right. So you can just guess. You can draw this arrow either way. But we do know that it is holding the bridge up. I drew the force of the car pressing down on the bridge, also the weight, and then a roller only has one reaction force, pointing upwards. It doesn't hold it from going back and forth. It only holds it from falling down. So these are called the support reactions, these right here. Notice they keep the notation nice and simple. This is pin A, so they're calling this the AX. So it's a force at pin A in the X direction. This is a force at pin A, and it's in the Y, the vertical direction. This is a force at pin E, and it is going in the Y direction upwards. So I have an example here for you guys, just like you're going to see on your assignment. A 1,000-pound car is parked at the center of a truss bridge that weighs 5,000 pounds. Draw a free body diagram of the bridge and solve for the support reactions. So you need to determine what your support reactions are at these 2 points. Notice, once again, this is a pin. And so for a pin, you're going to have a force going up, and then you can either draw this to the right or the left. The roller is holding it up. I said the car was 1,000 pounds. The bridge is 5,000 pounds. Now we're going to go back to what you guys did on the first statics assignment. You need to sum the forces in the X direction. And remember, you need to say which direction is positive. So I'm saying to the right is a positive X direction. Up is positive Y. So sum up your forces, and you're going to see this is a strange thing. We only have one X force. Sum it to 0. So this force is actually 0. It is not doing anything in this case. One of the problems, I'm going to say there's wind pushing the bridge to the left. Wind and things like that, it would counteract that and hold the bridge in place. But in this example, there's nothing pushing the bridge to the left or right, so that pin is applying no force in the exact direction. You should write that up on your diagram equals 0 once you find each force. The force is in the Y direction. These two are going downwards. That is your negative Y direction. So minus 5,000 pounds, minus 1,000 pounds. Holding the bridge up, going in the right direction. You're summing these up, so you're going to add AY going up, that's the positive direction, and EY going up. And remember, you sum to 0 equals to 0. Now you're going to do algebra, and you're going to get AY plus EY equals 6,000 pounds. I'm going to tell you that just take half of that, and that's what each force is in this case. We're not going to talk about moments yet. That will be statics part 3, where you'll have to sum the moments, set them equal to 0. For now, since this force is in the middle and all of the problems on your assignment are in the middle, assume that this force is divided between these two. And once again, I know this is a really easy problem where you really wouldn't need to do all this math, but I'm trying to give you a simple example so when you guys see something more intense, you've got the procedure down. We're trying to learn the procedure. So just use common sense here to check your answer. If you got 6,000 pounds going down, these got to be applying 6,000 pounds up to hold it from falling in the river. Then just divide that by 2, 3,000 pounds here, 3,000 pounds there, and your bridge is standing. Let me know if you guys have any questions. Next, we're going to talk about what if this force isn't in the center. That will be statics part 3.